Good morning from my side. Today I would like to tell a little stuff about using a GPU in a Citrix World, some things you need to consider, some things that are best practices. For those of you who don't know me, I'm Jan-Henrik Meyer. I'm blogging, I'm not self-employed. I'm part of the NVIDIA community program and of the small Citrix program. I'm not allowed for the big one as I'm working for Citrix. Besides that, I'm organizing a small community event in Hanover in Germany. I've published several books in the past around this area. So one is about the old LTSR release for Citrix, and one was around NVIDIA stuff. But now to the topic. We have some basic things that you need to consider when implementing in vGPU World. So there are 5 general rules. The first one is, from my point, the most important one. So adopt it to a use case. So set the right expectations. A lot of people go inside and say, hey, you put a vGPU in and you can scale thousands of users more. But that's not true. So you really need to look for a use case and adapt it to that. The second one is know your applications. Applications behave totally different. Know how they work, how they interact. A lot of people think, hey, you have a CAD application that's just using the GPU. No, a lot of CAD applications still use a lot of CPU for parts of it. The GPU is not used at all. Do a proper POC. So test it with your applications with a real workload and not like we do some synthetic tests or something like that. Decide your use case and do a proper POC to see if it's valuable for your environment. And choose one who has done it before. So choose a partner who has experience in the topic and is doing regular with these topics. Because if he has not done it before, he will fail in a lot of positions because he doesn't consider everything that is necessary. And last one, feedback. If you have feedback, give it or tell it other people, because otherwise it won't get better. Next thing, knowledge and experience are key. It's not the book. There are also a lot of manuals available from NVIDIA. Have a look at them. They're really, really good and useful. There are other blogs, so use these resources that are available everywhere. Especially the grid documentation is really good and really detailed. You just need to have a look at them. If you now look at the NVIDIA vGPU itself, you can see that it has quite evolved. So they started with the Kepler, continued with Maxwell, then Pascal, Volta, Turing. So the first decision you have to make is which GPU are you going to choose. You do need to consider Kepler, it's outdated, it's not valid anymore, but all the other ones are possible solutions at the current state, they are all supported. If you have a look more detailed look, there are GPUs typically used in a VDI world. So these are the Maxwell cards, the Pascal cards, and the Tesla cards. If you see all the data, you know why you need to know how it behaves, because there's a lot of things to consider. Like, if you take the M10, which a lot of people choose for a XenServer workload, it uses 2 slots in your system, compared to the T4, which is only using 1 slot. On the other hand, the M10 has 4 GPUs on 1 card, and the T4 only has 1 GPU on a card. So, besides that, think about power usage. Like the P4 has 75 watt, and the P40 has 250 watt. So that's are topics you need to consider when you're planning your server hardware. Last one. You can assign different profiles to the VMs, so how much frame buffer does a VM get? And this is also depending on the GPU you have chosen. The M60, for example, supports also a really small one with 512 megs. I would not consider that for any solutions, but it's available. And on the other hand, you have the P6, which goes up to 16 gigs of frame buffer for 1 VM. We have 2, 4, 6, 7 cards on this one. These are the typical ones. And if you like, and to get a lot of time, you can also look at other cards, the PR100 series and the V100 series. Most don't consider them for vGPU workloads. They work, but they are not designed for this scenario. They are more for AI, deep learning. So it's not typical to use them. Alex, don't look so angry to your screen.
No, I'm very positive.
When you've decided the graphics card, you have to think about the next step. It's the next step, it's the licensing. So NVIDIA decided to implement not only that you buy a card, you also need to buy a license. So you have a virtual apps, which is not only apps, it's also desktops, if it's used for XenApp. For XenDesktop, you have virtual PC, and for the high-end users, you have a virtual data center workstation. Freaking long name. And to make it even more nice, they added another one, the virtual compute server for compute workload. So that you have to really consider which one do you need. There are a lot of topics where people start to combine them, that they use like the virtual compute at night and the other ones at the day. So it might be even necessary that you need two types of licensing depending on your workload. Since grid 5 are NVIDIA reinforced licensing, that means when the VM is booted and there is no license available, the frame rate is capped to 3 frames per second. And then also, at some point, they limited the resolution. This has changed again. So it's now only the frame rate which is limited in the current releases, but that's still valid. And if you boot your VM and the agent registers too early and the NVIDIA didn't grab the license, the user connects and has a bad experience because NVIDIA licensing was not applied fast enough. So you need to consider to delay the registration of the VM so the NVIDIA license is correctly applied. NVIDIA is going to change its behavior, and I'm personally really happy with that. There are people who don't like that, but I personally like it. When you have decided which card you're going to choose and which license you're going to use, you have your next decision. The GPU configuration. When starting with the old Maxwell ones, they had two modes available. It was compute mode and it was graphics mode. It was not possible to use them in a vGPU scenario when they were running in compute mode. Thus, you had to change them. It's on the command line, and you only see a number, and it's like 300 or 302, and that shows in which mode the card is running. When it is running in the wrong mode, you need to change it to the according one to get it up and running in the vGPU world. With Pascal, this changed, and that was no longer necessary. But therefore, they had an ECC mode, and you needed to disable the ECC mode. When you stay with the licensing, or with the driver version 8.x or lower. When you didn't disable the ECC mode, which was the default selection, you got errors when booting the VMs, like this one, or this one on XenServer. Therefore, I hope it's still visible, you have to check the ECC mode, that it's off. And when it's not off, you need to disable it. So before you had to change from compute to graphics mode, now you have to disable the ECC mode. With grid 9, NVIDIA changed it again. ECC can now be enabled. So in theory, it's much more easy now because you can just put the card in and use it. This is really important because if you remember, you had this compute licensing, and in compute licensing or quadro profiles, you sometimes need the ECC function, but it's not available in lower licenses. So although it's enabled on the card, you can only use it in the specific licenses. So only in Q or C profiles. To sum it up, it looks like that. So I discussing with a colleague when to enable which, and I was like, I need to sort it out because I missed. Because like with Maxwell, you had to change it to graphics mode. ECC needed to be disabled. With Pascal, it changed, you could stay on compute mode, but if the driver was 8 or lower, you had to disable ECC, and now it can be enabled. So you really need to check which drivers you're using in your environment. The other point why people still use the 8 version is the 8 is the LTSR release from NVIDIA. So it's a long-term service release which will be longer supported. The 9 won't be as long as supported. There's another point. Who has heard about scheduling modes for NVIDIA cards? only a few. So that's, NVIDIA also changed scheduling modes in between. With Maxwell, you had no choice. You had to choose the best effort. Best effort means a VM requests a GPU cycle and gets it. So if a VM is really noisy, it gets a lot of GPU cycles, and other VMs are affected, so the performance might drop. So this might be a bad idea, but this was the only one available in Maxwell. In Pascal it's also available, but with Grid 5, they changed it to equal share. Equal share means when a VM is booted on a GPU, the GPU is sliced between all available VMs, and each VM gets a part of the GPU. So first VM gets the first slide, second, third slide is the first VM again. So it's equally shared, and when a VM is not using it, it just lost and the GPU does nothing. The point is, with equal share, the GPU is sliced between all available VMs. So if you boot 3 VMs, the GPU is sliced between the 3. If you boot a fourth VM, the GPU is sliced between the 4 VMs. Thus, the user might get less good performance, as he now has to share with more users. So the performance depends on the amount of VMs booted. With fixed share, this is somehow the same. So the GPU is sliced again into parts, but depending on the profile you've chosen, you can boot up to like 4 VMs. And with fixed share, the GPU is sliced directly into 4 partitions. Even if only 1 VM is booted, this one VM will only get a fourth of the performance of the GPU, because the other ones are reserved for possible VMs that can be booted. So you lose some performance, but for like cloud providers, this is the one they prefer, because they have no noise neighbor talking, the performance is always the same. So they really know how the environment behaves like. Next point, frame buffer. So next to like CPU, RAM, a graphics card also has a frame buffer, so the memory for the graphics card itself. And most people don't think about the frame buffer. They say, we just assign it and then it will work. We did some tests with XenServer where we had a really small profile. So the XenServer had only a 1 gig profile assigned, and we started 15 user sessions. And what you can see is the light blue one is the frame buffer, and with only a few users it's already at maximum, and after some time the GPU starts to spike a lot, the green one. So the frame buffer is fully centralized, and this leads to a lot of GPU usage because it now has to swap from frame buffer to a normal memory, which affects it. If you change it to an 8 gig profile, it looks much better, because now you have like a really low GPU usage, and the frame buffer just rises up with the users. In a direct comparison, it even looks better. So you can see with 1 gig frame buffer, it's fully saturized. So you need to know that frame buffer is never used above 90%. When it's around 90%, the GPU starts to put it over to normal memory. And with 1 gig, with 8 gig, it's just going up. When the frame buffer is fully saturized, you see this massive performance spiking in the GPU. So you really need to consider these points. When you add things like hardware encoding, those that like the video screens are rendered directly on the graphics card, this also has an effect on the frame buffer. So on the left hand, we have no usage of NVENC. NVENC is H.264 encoding on the graphics card. And on the right side, we have usage of NVENC. You can see that without NVENC, it's like 20% lower, 10 to 20% lower. And just because using the offloading of the graphic or of the hardware acceleration, so those H.264 is rendered directly on the graphics card, the frame buffer is even more used. On the lower end, you can see that the encoder, which is doing nothing here, is used here, and the GPU itself is not really changed. It's still really low usage. So a lot of people are worried that when they start with GPUs, that the GPU will be a bottleneck. But when you can see this workload, the GPU is not the bottleneck. It's a frame buffer or the CPU, which is the red one, where you can see which gets up to the top. Another point a lot of people don't consider is the screen resolution of the users. So we had a customer complaining about some performance issues, that they didn't get the scalability they expected with the GPU. And we did some internal tests with a colleague, and we said, in our test it looks completely different, the results. So where is the difference? At the end we figured out they had used different screen resolutions for their environment. So we said, okay, this is time for testing. So what have we done? We had a hardware, an old Xeon CPU, yeah, it's an old one with 256 gigs of RAM, connected to a NetApp SSD. We had the XenServer LTSR release, Windows Server 2016 with VDA 7.1808, NVIDIA Cards H.264, login VSI to generate some workload, and GPU profiler to measure the data. It's also a quite old VDA, but there's no big difference in using a new VDAs in this part. We had a look at the workloads, and in the other workload I used the multimedia scenario, because for me this is the typical normal user today with like Google Earth and looking some videos and stuff like that. But the customer only used the knowledge worker, so it's like mainly Office usage. So we also switched to only Office usage to get some workload. And we had two resolutions. One was 19220 and 1200. And we doubled it so that you have like from one screen to double screen to just see the changes. The VM itself had 4 vCPUs, we had 16 gigs of RAM, and we connected 15 users. To make sure it's no one-time exception, we did every test 3 times to see if there's like a change in one run or if it's always looking like the same. And then we started our testing, was like, okay, this is a small resolution, looks quite easy. You can see at the end you have 15 users, and what's interesting is that you have like 80% of RAM usage, not frame buffer usage. So if you dig in at the maximum users, you have 82% of RAM usage. You see here 22 sessions, although we only have 15 sessions launched. One is my admin session, where I collect the data, and 6 are like idle sessions, which are always counted. So the GPU profiler just counts the already running sessions. If we look at the details more, and just the interesting part, the GPU itself is quite running low, and the frame buffer is like going nicely up and not fully filled. And importantly, we have nearly 90% of frame buffer usage already. We are only talking about 15 users with one monitor connected. If we now extend this to 2 monitors, you will see a different one. First one, the 80% of RAM is used earlier.
Which workload is this? Is it the multimedia one or
knowledge?
Knowledge. Knowledge.
So it's just the knowledge worker. That's really important. With multimedia it would be much more. But the customer tested with knowledge, so we said, okay, we also test with knowledge just to get an idea of this. And I was surprised that with knowledge the usage was already that high. First thing, 80% of RAM usage is earlier. So we only have, like, you remember, we need to have 7 sessions. We only have 12 sessions left. So even the normal RAM is affected because of the bigger resolution. And the last session looks really short. It was never launched. So with just adding a second screen, I was not able to any longer start 15 sessions. I only was able to launch 14 sessions on the environment. So even the system completely was so much loaded that it dropped. If you look at the details more, it goes up, but much more steep. And it also starts, you can see that the GPU starts to spike at the end because it's fully using the frame buffer, and there won't be any changes. So if you go in, you have around 92% of frame buffer usage with only 11 users connected. So not 50, 11 users already fully use the frame buffer. If you do an overload, I think it's really good to see the difference, because you have like the low one with one screen and the other one with two screens, and you can see that just because the user has added a second screen, you have like 20% more frame buffer usage, which most people don't consider.
How much frame buffer this was? How many?
8 gig.
8?
8.
Wow.
So it's a P4 with 8 gig, and people don't consider that when designing their environment, that with 11 users you can already max out the frame buffer. Because they just say, XenServer can like easily run 20-25 sessions. Yes, if the user has a small screen and doesn't do anything, and we're just talking about office workloads. Add some multimedia workload, and it will go up more, even go up more. So that's why the scalability of the servers go really down, and the people don't think about that point. Next to that, we have some HDX configurations. You need to choose the right codec for the right use case. I really love these pictures with the different colors, because you can see with H.264 4.2.0 mode, it's like blue on red, it's really not readable. If you change it to H.265, it's much better. But in H.264 4.4.4, full screen, which even costs more performance, so that's another topic, it's much better to read. So you really need to look for your use cases, which setting you choose to deploy to the users. Because for some users this might be fine, because they don't need this contrast, and other ones require to be able to read stuff like that. So there's a really big difference inside. Oh, it's readable. There are only a few configuration changes. So you mainly have, like on the last one, that it's visual quality is full lossless. On the other hand, if you change these settings, there are other points you need to consider. So you see the screen, it looks quite nice. Average bandwidth use is around 5 megs. And we are using H.264 with 4.2.0. We change the setting, and I bet you can't see any difference if I switch. So the screen for the user looks exactly the same, except that it's not 100% aligned. But if you now look at the average bandwidth users, we are talking about 50 megs. And we are use 4.4.4 with H.264. So just because of changing to full screen, we now have like 3 times the bandwidth requirements. Not an issue in LAN environments, but if you have WAN environments with people far away, we really need to think about these points. Hardware encoding, the point I mentioned before. So hardware encoding means you have areas of your screen or the full screen, which is running in H.264. And the NVIDIA cards have a special chip on it to encode this stuff. Why is this useful? Well, it helps to reduce your CPU load. So if you have it not enabled, you have like of the graphics process of CTX when it's full screen, like 10-15% graphics usage. And if you change it so it's enabled, it goes down to like 2-4%. So it's much less. Same on Linux. Most people don't consider Linux. It's the same on Linux. You have like 30% without enabled. If you enabled it, it goes down to like 8%. So the usage of the CPU is much lower just because utilizing something on the graphics card which is available and is dedicated to this encoding. So that's an important point. It's not using the normal GPU, it's a separate chip on the GPU. But everything has 2 sides. To activate it for changing regions, it's quite easy. You say video codec for actively changing regions and use hardware encoding, enabled. If you do this for full screen, it's in theory for the entire screen, enabled, it won't work. You also need to enable optimize for 3D graphics workload, otherwise it's not using the hardware encoding. So it's different on the selection you have if you need to enable optimize for 3D graphics workload or not. If you have the other one, the setting 3D graphics workload has no impact. So if you now think, it's all fine, I just put everything on the graphics card and my users are running fine, there's another point you need to consider when planning your graphics card. Because if you have a deeper look, for H.264 streams, they are limited depending on the graphics card. So an M10 is able to handle 28 streams, in contrast to a current T4 which only is able to handle 17 streams. Each monitor is a stream, so if a user has 2 streams, which is 17, this might already become a bottleneck. It's not always, so you really need to properly testing it, because it depends how the users behave, if they're really actively using it. But it's the point you need really to consider, and people don't think about this point, that they need to think about the number of streams. H.265. H.265 again changed the game a little bit. So it's the evolution of H.264. Higher quality, lower bandwidth, but more resources are required for encoding this. So I've seen scenarios in van where people are using this for construction stuff, and the user said with H.264, no, it's not usable. And with H.264, the performance was so much better that they said, oh, it's now better than my local notebook, which I used before for construction. So it really has a huge impact for the user, but it also has a huge impact on the system load. What do you need to know about it? Maxwell, Pascal, Walter cards. Oh, I missed Tesla. Tesla would also be possible, of course. Citrix Platinum licensing. On the client side, you need a Windows Receiver 4.10 or higher, and you need to enable the setting that the receiver does this. So you need to enable the policy to enable H.265, which is an endpoint policy. So you're not deciding this on the VDA, you're deciding this on the endpoint. And again, think about the different use cases, the different results when using H.264, H.265 with the contrast issues. How do you know it's working? You can use the HDX monitor, where you can easily see it. You can use the RD analyzer, which shows it. And the NVIDIA SMI command also shows you if it's used or not.
Direct doesn't record it?
It's a pretty good question.
Yeah.
I think so.
I think it should.
I'm not sure. No. In the current version, pretty good question. I've not looked it up.
Can you go one slide back?
For sure.
You said a backgraph Intel HD graphics driver to eliminate green banding. Does it have anything to do with the new DCH drivers, or?
No, when using H.265, the endpoint must be compatible, and with Intel you have sometimes issues, so you really need to check that your endpoint works with H.265 decoding. So it's nothing related to the VDA. The endpoint really must make sure that it can decode it. So people tend to, we just enable this, and then they have old fat clients, 10 years, and they are not able to decode this properly, and then you have an issue again.
Does this also work for Mac OS or Linux workspace?
No, not yet.
No, for Citrix it's more like any device. Any device? No, any device. Is it only Windows? For the IOV 444 and this H.265.
It's currently only Windows, but if you have a look at Citrix development of clients, it always was the first client, and the other ones follows when there's enough interested customers. So H.265 only really few customers start using it because you have this huge impact on the systems. So there's no demand for getting this into the other ones. I think they are working on it for Linux.
Because it has to be a managed endpoint, because you have to set the registry, or you have to explain how to do it.
Yeah, I know. Honestly, I personally don't like it that it's an endpoint setting. I would prefer that it's a VDA setting, because on my VDA side I have no chance to configure this behavior.
Tell the receiver to do it by using the command to the screen.
Yeah. It's not only registry, you can also do it with a GPU, but if it's an unmanaged endpoint, you're ended with a registry. But the point is, H.265 really is a special use case. So you need more server resources, so you really need to consider if it's valuable to use H.265. If you have advanced scenarios, definitely test it. It will help you. For advanced scenarios, it's not a big difference, except for the visual quality. And again, the card limitations, if we look at H.265 and the M10, which is often used in XenServer environments, doesn't support any H.265. So even that, you need to consider that. Is H.265 an option you need for some use cases? Then you can't use the old M10 card. The M10 is still really valid and NVIDIA supports it. The other point is, before I've said, when we have a number of limited streams available. So with H.264, we have like 335 frames possible, and with H.265 it drops to 223. So even that has a huge impact on the graphics card. So you generate much more load and can put less users on it. Same for Pascal. Last point, there's a lot of free stuff inside the vGPU world that you can utilize to have a look at. So you have the HDX monitor from Citrix, you have the remote display analyzer, which is an awesome tool because if you take the license version, you can change settings on the fly and change from like one point to another, one configuration. So you can test the different configurations really, really easily and see how it looks for the user, so you get an idea. You have the connection quality tool, which gives you a good insight into the environment. And you have DXVH checker, which the ballooning, which is available in Citrix, also got some pretty nice improvements in the last version. So in the past you had this visual lossless switch, only available for visual lossless. If you now enable this tool, it also gives you some details about your connection, like is H.264 used or H.265. So it has really evolved in that area. Any other questions?
And this one screenshot, I've seen Windows 7 as operating system.
Yes.
And what about Windows 10? And
Same. So NVIDIA, according to NVIDIA, Windows 10 is of course heavily more using the graphics card. In the first slides, NVIDIA said it's 30% more. In the current slides, they say the current Windows version uses 50% more GPUs compared to the past. So it's really helpful for the users to use this stuff. But when implementing it, you have seen there are a lot of things that you need to consider. So it wasn't just like a rush through the important points. And people don't consider like frame buffer. If you like take a Windows 10 with a 4K screen, you might be sufficient with a 1 gig profile, but mostly it won't work. So NVIDIA has extra introduced for normal workers a 2 gig profile for the 4K screens.
That's one screen.
One screen, yeah. And you have seen the impact of the two, just adding a second monitor on the frame buffer. It was like poof, it was fully centralized. And even the system itself was not able to handle all users like before. So before it was able to run 15 users, and now it's only able to run 14 users. I didn't expect that even the users are running into issues and cannot be launched any longer just because adding a second screen. And that was the issue the customer had as well. So they scaled and it was like, it's not working. And they just have a lot of users with big monitors. Any other questions? So, 6.